Hey there, science explorers. Welcome back to the channel. Today we are unlocking the secrets of the modern periodic table and discovering how the properties of elements change in a very particular way. Ready to learn some science magic? Let's go. The modern periodic table is arranged by atomic number, which we can see here in the table that hydrogen has the atomic number 1. Similarly, helium has 2. So the numbering that is given here, that is the atomic number or the proton number in an atom's nucleus. As you go across a row, that is called a period, which is this, or down a column, which is called a group, the elements change, but not randomly. They follow certain trends because of the way electrons are arranged in atoms. Let's first explore what happens when we move left to right across a period. Let's take the second period, which is lithium to neon. So here we are going to talk about the characteristics that are changed. We can see a certain trend here. Let's talk about that. Okay, so the atomic number. Each step adds one more proton to the nucleus and one more electron to the same energy level, which is why the atomic number increases along the period. For example, in case of lithium, what is the atomic number? It is 3. But for carbon, the atomic number is 6. So the atomic number is increasing across the period. Along with the atomic number, the atomic radius is also changing here, but the trend is different. Atomic radius decreases across the period. Even though we are adding electrons, they are being pulled in closer. Why? Because the increasing number of protons creates a stronger positive charge, pulling electrons toward the nucleus. So the atom gets smaller. So lithium. It may seem smaller than the other elements present in this period, but it's actually larger. So the atomic radius is decreasing across the period. As we know, all the metals are present in the left side. So if we take the second period, we can say that lithium and beryllium are metals here. And if we move further, for example, fluorine is here, it is a non-metal. So the metallic character is decreasing across the period. That's why elements on the right side, like fluorine, act more like non-metals. And what about the electronegativity? What is electronegativity? It is the tendency of an atom to attract electrons in a bond. For example, if we take the hydrochloric acid or hydrogen chloride, that is HCl. So hydrogen is the first element of the periodic table, and chlorine is present in the 17th group here. As we know, the electronegativity is increasing across the period, so we can say that fluorine is more electronegative than hydrogen. That's why it's pulling all the electrons towards itself. So this is electronegativity. Now let's talk about ionization energy. Ionization energy is the energy needed to remove an electron from the outermost shell of an element. So, from left to right, ionization energy increases. So, if we take the third period here, we can see the first element is sodium. And what is the electronic configuration for that? It has 11 electrons. So the configuration will be 2, 8, and 1. So we can see the outermost shell has only 1 electron. And it's pretty easy to remove that because it's not that tightly held. But if we talk about the configuration of aluminium, the atomic number is 13, which means the configuration is 2, 8, and 3. So there are 3 electrons in the outermost shell. And we can expect more than one ionization. In conclusion, we can say that if we move from the left to the right, the ionization energy increases. These are all the characteristics that changes along the period when we move left to the right. Now let's talk about the trends down a group. We have learned that the atomic number increases along the period and the size decreases along the period. But if we move from up to down, we can see that the atomic number and the size both increases. Each element down the group has an extra electron shell, making the atom larger. Even though the nuclear charge increases, the outermost electrons are farther away and feels less attraction. And we have learned the metallic character decreases along the period. But it's different for the group. If we move down the group, the metallic character actually increases. Larger the atoms hold on to their outer electrons less tightly. That makes it easier for them to lose electrons. So metallic character increases down the group. For example, the first group where we can see lithium, sodium, potassium and other elements. The metallic character is actually increasing down the group. And electronegativity. Larger the atoms, less is the tendency for them to pull the electrons strongly because their positive nucleus is shielded by inner shells. So electronegativity drops. It is more prominent in the 17th group, which is called the halogen group, where we can see fluorine is on the top, which is the most electronegative element on this periodic table. But as we move down the group, the electronegativity decreases. And in case of ionization energy, that also decreases. It's easier to remove an outer electron because it's farther from the nucleus and not held tightly. That's why elements like cesium and francium are so reactive. They lose electrons easily. Ionization energy for the element lithium is the largest, and for francium, it is the lowest. Understanding these trends helps us predict how elements behave in real life, in chemical reactions, in nature, and even in your smartphone battery. For example, sodium reacts with chlorine. Here is sodium and here is fluorine. Sodium is a metal and fluorine is a non-metal. So when they react with each other, they form salt, which is sodium chloride, because they have different positions in this table. One easily gives electron, sodium, which is 2, 8, and 1. So this one electron, it can give up easily. And chlorine has atomic number 17. So the configuration is 2, 8, and 7. So it just needs one more electron to get the octet filled, like argon. So sodium easily gives an electron and chlorine takes it. So they make a bond and they form the salt called sodium chloride. So there you have it. The periodic table is not just a list of elements. It's a map that shows us how atomic properties change in a logical and predictable way. If you learned something new today, hit that like button, subscribe for more awesome science content, and drop a comment. Which trend surprised you the most? And here's a quiz for you. Which element has the highest electronegativity? Tell us in the comment section. Thank you for watching. Bye bye. See you in the next video.